Hi everyone, this is Mr. Murray. I'd like to do some review for your test on Friday. So the answer key is online, and I'm just going to review a few questions for you on a video in case you wanted some further help. So let's just take a look at some of these randomly. I have 7, 8, 12, 14, 17, 19, 20, 21. Okay, so I'll go through those and hopefully this will help you out. So number 7, multiplying fractions. The whole idea here is factor and cancel. Whatever's left is your answer. So 3x, sorry, 3x is 3x. There's nothing I can do with it. However, the bottom is dots, so we would factor that to be x plus 3x minus 3 multiplied by, okay, 6x minus 2x squared. To factor that, it's not dots, but I could GCF maybe 2x out of there, leaving me with a 3 minus x. Okay, over, same thing here, GCF. 2x would be the GCF on this one. If I take 2x out of here, I'd be left with x minus 1. Okay, now that we've factored everything, you just cancel. You find pairs that match. You can cancel crisscross or up and down. You just can't go sideways. That's not good. Okay, so let's start with the easy ones. 2x, 2x. They can cancel to be 1. All right, well that's it. Now this one, 3 minus x and x minus 3. I can cancel those for sure. However, they're opposite factors, so let me put a negative 1 up top. Now, is there anything else I can cancel? I don't think so. So the final answer is negative 3x over x plus 3, x minus 1. That's it. Number 8, same idea. We want to take this division, turn it into multiplication. How you do that is you flip the second fraction. Like that. Turn it into multiplication. And now let's do some factoring. So this guy here, x squared plus x minus 6, and this one, x squared plus 6x plus 9. If I wanted to factor these and then cancel, I think I'd use the AM method. Or you could do earmuffs, whatever you're into. This is really just an exercise in factoring. So I would factor this to be what adds up to 1 multiplies to negative 6. 3, negative 2. Okay, the bottom one. What adds up to 6 multiplies to 9. X plus 3, x plus 3. Okay, that's good. Up top looks like a GCF again. And on the bottom's just a 1. Okay, where do we have matches? So I have an x plus 3 here, and x plus 3 here. An x plus 3 here, and x plus 3 here. Nice. Okay, nothing else. So whatever's left, you simply multiply across the top. So that would be 2 times x minus 2. And on the bottom, it's just a 1. So that's your answer. Again, the main idea here with these division problems is that you change to multiplication and then flip the second fraction over. After that, you're just factoring and finding matches to cancel. Now let's talk about adding and subtracting fractions. You need a lowest common denominator. The lowest common denominator between a 12 and a 3, I would say, is 12. Now, you have to go back to each fraction and say, what do I need to do to you so that your denominator is equal to 12? Well, if you look at the first fraction, there's nothing at all because it already has a 12 on the bottom, so we're happy. However, the fraction on the right has a 3 on the bottom. In order to make that a 12, I'd have to multiply by 4. And in order to be fair to this fraction, I should multiply top and bottom by 4. Because after all, 4 over 4 is 1. And if you multiply anything by 1, you're not actually changing the value of it at all. You're keeping it the same. But we're certainly making it look different. And how we're making it look different is as follows. 4y minus 8 over 12. Now look, the denominators are the same. Therefore, we can just do the operation and put the answer over 12. So let's draw 12. And being very careful with this minus sign, I'm going to use parentheses. So I have y plus 7 minus 4y minus 8. The reason I do that is so that I remember that that minus sign applies to both. So let's rewrite this. Y minus 4y, that would be negative 3y. 7 subtract negative 8. That's a double negative, so it really turns into addition. That would be 7 plus 8, which would be positive 15. Putting that over 12. Now, this answer can be reduced. And to reduce fractions, you need to factor. So let's GCF the top. Let's take out maybe a 3. And then we would have y, negative y, plus 5 all over 12. That's helpful because by factoring, we've now enabled this reducing right here. 1, 4. Because 3 goes into 3 once, 3 goes into 12 4 times. So our final answer is negative y plus 5 all over 4. Okay, so this one, number 14, adding two fractions, again, you need a lowest common denominator. But what you need to remember is when you see this situation, that those are opposite factors. Remember this, x minus 2 over 2 minus x, that's equal to negative 1. So, I can easily make these denominators the same by simply taking one of them and multiplying top and bottom by negative 1. And essentially what that does, the only thing you really need to remember about this, is that you can now rewrite these fractions as follows. Change the operation. If it's plus, make it minus. If it's subtraction, make it addition, okay? So just change this operation. And don't change the top. But now, make the bottom the way you need it to look, which would be x minus 2. So if you have opposite factors as denominators, to show your work, put negative 1 on top of negative 1 as a multiplier, but then just know that all you have to do is switch the operation and change the denominator of that fraction to the way you need it. So now look, they're both the same, so what do? We combine the tops using the operation that we had to, so that's subtraction. Use the parentheses, especially with subtraction, and that's our starting point. Now if we combine like terms, x subtract negative x, well that's a double negative again, so that would be 2x. Negative 1 subtract 3, that's negative 4. And that's on top of x minus 2. Now this would normally be our answer, but we have to reduce fractions. And the way you do that is factoring. So I'm going to take the 2x minus 4, and I'll be able to GCF it like this. And the bottom is already factored, so I can't do anything. However, look what just happened. I will now cancel those, and my final answer is 2. Cool. Okay, long division. This is long. The way you set it up is you make sure that everything is in order. So we want to make sure that we have an n to the 4th going first, then the n to the 3rd, followed by n to the 2nd, n to the 1st, and then the number. If any of those are missing, remember that you need to fill them in with zeros. But in this case, we had everything, so that was nice. Okay, so this is how you do long division. All you worry about is the first terms in both. And you say to yourself, how do I go from n to 6n to the 4th power? And to do that, I would say you'd need to multiply by 6n to the 3rd. Now, after you figure that out, you now multiply the 6n to the 3rd times both of these terms and write them underneath as a subtraction in parentheses. So 6n to the 3rd times n is what you would expect, 6n to the 4th. 6n to the 3rd times negative 3 is negative 18n to the 3rd. Now we perform this subtraction. These go away. That's what you wanted. Negative 9, subtract negative 18. Again, that's a double negative, so we're really going to add. So this becomes positive 9n to the 3rd. Now bring down your next term, and let's continue this process. Again, first terms only. How do you go from n to 9n cubed? I would say you'd multiply by 9n squared. Take this 9n squared and distribute it to the n minus 3 in parentheses as a subtraction. So as expected, 9n cubed, and then 9n squared times negative 3 is negative 27n squared. N to the thirds disappear. Negative 24 subtract negative 27 is going to be positive 3n squared. Bring down the next term, and let's continue. How do you go from n to 3n squared? You would multiply by positive 3n. Distribute the 3n to the two terms here. You would get, in subtraction, parentheses, 3n squared minus 9n. These go away. Negative n, subtract negative 9. That's really addition. That's going to be 8n. Bring down our last term, negative 24. How do you go from n to 8n? I would say you'd multiply by 8. Distribute, in subtraction, parentheses, 8n minus 24. Wow, everything goes away. Therefore, you have a remainder of 0. Okay, so number 19, this is a way to use long division to show if numbers are roots of this polynomial. So this question is saying, let's use two ways. Okay, well, first of all, let me order this because I don't like the way this looks at all. Let's go highest to lowest. B cubed plus b squared minus 8b minus 6. That's much better. especially since we're going to have to do long division anyway. So if negative 3 is a root of this polynomial, or this function, well, that just means if you plug it in, you get 0. So let's do that. If we take negative 3 and we cube it, and then we add that to negative 3 squared, and we take away 8 times negative 3, and then when we're all done, we subtract 6, does that equal 0? If so, well then negative 3 is a root. So let's figure that out. Negative 3 cubed is negative 27. Negative 3 squared is 9. Minus negative 24, so that's actually positive 24, minus 6. These two terms combine to be negative 18. These two terms combine to be positive 6. And these two terms combine to be 0. So this equals 0. So we're happy. Negative 3 is definitely a root. Now here's the other way you can do it, and this is how using long division can be very powerful. If you take negative 3 and turn it into a factor, like remember the t-charts, right? Imagine you had this, because this came from some t-chart business, and then you solved and said, oh, b was negative 3. Well, that's where this came from. So let's back it up and make it a factor. Let's make it b plus 3. And let's see if we divide b plus 3 into b cubed plus b squared minus 8b minus 6. If this goes in evenly and there's no remainder, well then that's another way to show that negative 3 is definitely a root, or a 0, of this polynomial. So let's do some quick long division. Remember, first terms only. How do you get from b to b cubed? You multiply by b squared. Now we distribute with a negative sign and parentheses. So b third and 3b squared. Do the subtraction. These go away. B squared minus 3b squared would be negative 2b squared. Drop down your next term, and let's go again. How do you go from b to negative 2b squared? I would say multiply by negative 2b. Let's do that multiplication, putting it inside a subtraction and parentheses. This would be negative 2b squared minus 6b. These go away. This is a double negative, so negative 8 plus 6 is negative 2b. Let's bring down this final term, minus 6. Okay, last time. How do you go from b to negative 2b? Multiply by negative 2. Let's distribute. What do we get? Negative 2b minus 6. Look at that. Everything disappears. You have no remainder. That means this is a factor of that, and that means that negative 3 is a root or a 0. Those are your two ways to show that a given number is a root or a 0. Okay, so vertex form, that's this. Let's remember that. Vertex form looks like x minus h squared equals 4p times y minus k, not squared. H and k are your vertex. P is the distance from vertex to directrix, or focus to your vertex, or 1/2 the distance of your directrix to focus. So let's draw this out. I'm just going to sketch it. I don't have a picture of that graph, but you get the idea. All right, the focus is 2, 5. So 1, 2, 1, 2, 3, 4, 5. Right there. There's my focus. We'll call that F. Now, the focus is always inside the parabola. My directrix is at -1. So that's right here. That's my directrix. Y equals -1. It's important to know that a parabola will always aim away from a directrix. It's scared of the directrix, so it goes in the other direction. So this is a hideous drawing, but let me see if I can move it over a little bit. Nope. Here we go. Okay, so where does this parabola land? It's going to be somewhere halfway from the focus to the directrix. So halfway. So I'm thinking if this is 1, 2, 3, 4, 5, 6. If the distance here is 6, I'm going to go 3 down. And right there, I'm going to place my vertex. Like that. And this distance is P, and so is this distance. They're the same. So how much is that distance? It's 3. Is it positive or negative? It's positive because the parabola opens upward. So positive P because of this. Our end behavior is northbound. So now let's put that into this equation. So what you do is you take your vertex. So my vertex we found was 2, 2. And you change their signs as you place them into this equation. So I go from 2 to -2 equals 4 times P times y minus k. So y minus 2. Little bit of cleaning up. X minus 2 squared equals 12 y minus 2. That's it. You're done. So a couple of things that are really important. Wherever your focus is, in this case it was here, the parabola has to surround it. The focus has to be sitting inside of a parabola. Another thing that's important to know is that your parabola opens away from a directrix. And lastly, you need to know that P can be found in 2 different places. It can be from the focus to the vertex or from the vertex to the directrix. Or if you really want to be crazy, you can take the entire distance from the focus to the directrix and just cut it in half because this whole thing is really, really symmetrical. Okay, so that's the answer to number 20. All right, this last one's a bear. 21, 3 variables, 3 equations, system of equations. What are we going to do? So we start out by numbering them. And let's eliminate a letter. Let's eliminate a letter. I'm thinking, just by looking at this, that we can eliminate the x's pretty easily. If I just add these 1 and 2 together, these x's would disappear. So let's do that. Let's work on x's first. We'll get rid of all the x's. So this is my plan. Ready? Eliminate x by 1 and 2 first. Then 2 and 3. Because all I'll do is just multiply this last equation by 2, and that will give me a positive 6x. So they'll be ready to go. So then 2 and 3. Okay, so let's do the first one. 6x plus 3y minus 2z equals negative 13. Second equation was negative 6x minus 6y minus 5z equals 17. Let's add these two together. Bye-bye x's. I now have positive 3 minus 6, which is negative 3y. 2z negative minus 5, that would be negative 7z equals negative 13 plus 17, which is 4. Okay, this is equation number 4. Now let's do 2 and 3. So negative 6x minus 6y minus 5z equals 17. Let's multiply this entire equation by 2. That would give me 6x minus 12y minus 12z equals negative 18. Add these together. The x's go away. That's beautiful. Negative 6 minus 12 is negative 18. Negative 5 minus 12 is negative 17. And 17 minus 18 is negative 1. That becomes equation number 5. Okay, so now looking at 4 and 5, let's get rid of another letter. So let's place them on top of each other and see what we can do. Negative 3y minus 7z equals 4. Negative 18y minus 17z equals negative 1. Okay, how about this? Let's get rid of the y's. And to do so, why don't we multiply the top equation by negative 6. This way, the top has positive 18, the bottom has negative 18, and when we add them together, we'll have nothing but z's left over. So this is awesome. Okay, let's do it. 18y plus 42z equals negative 24. And now that's going to be on top of negative 18y minus 17z equals negative 1. Adding those up, goodbye to the y's. 42 minus 17 is 25. Z equals negative 24 minus 1, negative 25. Oh, this is cool. Now we can actually solve for z. Divide both sides by 25. Z equals negative 1. That's my first answer. So what did we do? You have to pick a letter and go all the way. So when I looked at 21, I saw that the 6x and the negative 6x would cancel. And then I saw that the third equation had a 3x, which can easily look like a 6x. So I figured, let's start with the x's. So we crushed the first two together. That immediately got rid of the x. We multiplied the third equation by 2, so that when we crushed together 2 and 3, those x's would disappear. And what that left us with was two equations. They both had y's and z's in them, but no more x's. So then we set up a new system of equations that just had these y's and z's, and we said, okay, which letter would be easy to get rid of? So I picked the y's because all you had to do was multiply by negative 6 to the top, and that would cause the y's to disappear. And if all you're left with is one letter, like 25z equals negative 25, you can solve for that letter, and that's what we did. We got z equals negative 1. So what you do is you take this, you go back to any one of these two equations, plug in z equals negative 1, and what will happen is you'll find out what y is. So let me pick this guy, just randomly. Negative 18y minus 17 times negative 1 equals negative 1. So negative 18y plus 17 equals negative 1. Take away 17 from both sides because I'm now trying to solve for y. And I get negative 18y equals negative 18. Okay, that's easy. Divide both sides by negative 18, and there you have it. Y equals 1. There's your second answer. So we have z equals negative 1, y equals positive 1. What you do now, the very last step, is go back to an original equation, 1, 2, or 3, whichever one you want. And you're going to plug in z is negative 1 and y is 1. That will let you very quickly solve for x. So let's just take the top one. Again, just random. I picked the top one. Let's solve for x. So let's plug it in. 6x plus 3 times 1, because now we know what y equals, minus 2 times negative 1, because we know what z equals negative 13. 6x plus 3 plus 2 equals negative 13. 6x plus 5 equals negative 13. Subtracting 5 from both sides, 6x equals negative 18. Divide by 6. X equals negative 3, and there it is. Your final solution. Your final solution would be in order, x, y, z, right? Negative 3, 1, negative 1. I hope that was helpful, and I wish you good luck on your test. Good night.